So we took a look at where vertical asymptotes occur. Now I'm going to take a look at where horizontal asymptotes may occur. So you can determine the horizontal asymptote by comparing the degree of the numerator with the degree of the denominator. That is, if we have a function y is equal to ax over bx, where ax and bx are polynomials respectively, and provided that bx cannot be equal to 0, feel like that's an important statement to make, we really look towards the degree. And there's going to be three cases. So case one, where the degree of numerator is less than degree of denominator. Under this special condition, we are going to have a horizontal asymptote of y is equal to 0. So I'll give you a few examples where this might be. Y is equal to 1 over x squared minus 4. Now what really matters is we look at the degree of the numerator, look at the degree of the denominator. Now recall that degree is simply the exponent, the highest exponent above the variable. Well, the degree of the numerator or of any constant is 0. The degree of the denominator, well, that has an exponent 2. The exponent or the degree is 2. So what we see here is the degree of the numerator is less than the degree of the denominator. So therefore, we have a horizontal asymptote of y is equal to 0. Same could be said for y is equal to x over x squared plus 9x blah, blah, blah. The degree of the numerator here is 1. The degree of the denominator is 2. So since we're talking about degrees, since the degree of the numerator is less than the degree of the denominator, again, we're going to have a horizontal asymptote of y is equal to 0. So that's case number 1. Case number 2. It's when degree of numerator is equal to degree of denominator, then. Now, we're going to have a horizontal asymptote at y is equal to c over d, where c, d are the coefficients of numerator and denominator. So I'm just going to have to get rid of case 3 here for a second. I'll come back to it. And denominator, respectively. So, for instance, y is equal to 2x squared over 3x plus 1, x minus 1. So the degree of the top is 2. The degree of the bottom is 2, because when you multiply these things together, you'll get x squared. So they both have a degree of 2. So the degrees are equal. Then what do? Well, we simply have to look for the coefficients in front of the numerator and denominator respectively. So here we have a horizontal asymptote of y is equal to 2 over 3. Also, if we have y is equal to x over x minus 4, what we notice is the degree of the top is 1, degree of the bottom is 1. So the degrees are equal. So then we go to the leading coefficients. There's actually a 1 in front of that x, although we don't write it. There's a 1 in front of that x. So we have a horizontal asymptote where y is equal to 1 over 1, or probably better put, as y is equal to 1. All right, let's go to the last case. I hope that's clear, and I hope you're able to fit it in this notes. Now, I'm just going to delete what I just wrote because I need space for case 3. So we talked about the case where the denominator or the degree of the numerator is less than the degree of the denominator. We talked about the case where the degree of the numerator is equal to the degree of the denominator. Now we need to discuss the degree when degree of numerator is greater than degree of denominator So when the degree of the numerator is greater than the degree of the denominator, we have no horizontal asymptote exists. Now, this is the world you're used to. This is your first time where we have an asymptote. But one example will be when we had this. We see that this appeared like a straight line, but this did not have a vertical or horizontal, this did not have a horizontal asymptote. The degree of the numerator is 2, the degree of the denominator is 1. Also, sometimes people think that this can be interpreted as a rational function. Because the degree of numerator is 1, the degree of the denominator is 0. Although we just write it as x minus 1. So it doesn't have a horizontal asymptote that exists. These three rules are kind of important. So these are just rules that we're going to follow. And if you want, I perhaps may make an additional video that helps to explain maybe why does this occur. It's an interesting conversation and argument, one that's fairly mathematical and fun. So I think that it's really critical to factor out anything that you can. And the vertical asymptotes should pop off the page. And just never be surprised if one factor cancels out with another. So there are other important points that we can determine when we're dealing with rational functions. One is y-intercepts. How do you figure out a y-intercept? Well, you find out a y-intercept by letting x is equal to 0 and finding out the value. To determine an x-intercept or any zeros, you determine where the y values are equal to 0. This is a little bit more complicated. Anyways, stay tuned. Let's start putting stuff together. I'm sure it's going to be